We're all on 113, yeah? Okay. You guys are smart kids. I know when you see that, you all say, I can do the shortcut. But I don't want you to, and I have a reason, okay? I want you to do this the long way, because A, it will help you practice for the quiz you're about to write, and B, it will prove a point, okay? So let's do this the long way. The first term is x. What is the first thing x must multiply by? X. So I'm going to do that, and I'm going to get x squared, yes? What is the next thing x has to multiply by? -4. And so I'm going to get -4x. Is everybody okay with that? First and outside, yeah? Okay, then I go to the next term, +4, and I do the same thing. +4x. So where should I write it over here? Under the x to keep the x's together, yes? And then 4 times 4 is -16, yes? And then we would write it out. And this would get me x squared. What does this add to? Plus 0x minus 16, yes? Everybody with me? Now, look at that and look at this. Where is it? Where did it go? Where did it go? Where did it go? Where did it go? Ah, there it is. Does that look similar to that? What is the same? The other term that we had was x squared minus 0x minus 81. Describe to me, in your own words, the similarities between those two trinomials. They're not triangles. The middle term is 0. So, in reality, would we write that middle term? No. So this should really be x squared minus 16, shouldn't it? And what should this really be? X squared minus 81. Excellent. Now tell me any other similarities you see between the two red binomials. Pardon me? They both start with a squared. Excellent. What else is the same? They are both binomials. They are both subtraction. And both of these are what? Perfect squares. Right? Everybody with me? Now you will notice that when we factored this, right, we ended up with x plus 4, x minus 4, correct? Because when we factored it this way, we remember from yesterday that we need numbers that multiply to 16 and add to 0, yes? Multiply to -16. And it was 4 and -4, right? Right? And when we did 81, we knew it was -9 and +9, right? Okay. Look closely. X squared minus 16. That's the expanded form, right? This is the factors, yes? I forgot the C. Factors, yes? What do you notice about that and that and that and that? It's the square roots. aren't they? So, if you get an expression that has a square and a square, do you automatically know how to factor it? Yes. You take the square root of the first one, x and x. You take the square root of the second one, 4 and 4. And what do you put between them? Plus and minus. Please notice that it only works when it is a difference of squares. Does everybody understand? Okay? Now, let me ask you this. What do I need in an exponent to be a perfect square? Something about that tells me that it can have a square root. What? Does x squared have a square root? What is it? X. Because x squared is really x times x, isn't it? And I can take out a group of 2, correct? Everybody agree? Okay. Does x cubed have a square root? Why? Because it's naughty. It's xxx. Can I get out a group of 2? Yeah, but it leaves one under there. Okay. Does x to the 4th have a square root? What is it? Why is it x squared, L? Because it's xx, xx. There's one group of 2, x. There's another group of 2, x. 2 x's make what? X squared. So x4 works. Does x5? Yes or no? No. Does x6? Yes. So now you can answer this question. What has to be in that box for there to be a square root? Right. The box has to be even. Is everybody ready to try this? Okay. Let's look at number 1. Is the first term a perfect square? Why? It's even. So we make it through the first check, right? First term's a perfect square. Is it a difference? Am I subtracting? In number 1. Yes, so I make it through the second check, don't I? Third check. Is 1 a perfect square? Does 1 have a square root? 1, because 1 times 1 is 1, right? So is this a difference of squares? Yes, which means I can follow my rules. I take the square root of the first one. What's the square root of x to the 16th? X to the 8th. Because x to the 8 and x to the 8, 8 and 8 would make 16, right? So I have x to the 8 plus the square root of the second one. What is it? 1. And then I just have the same thing with a minus. Is everybody okay with that? Everybody's good? Okay. Now look closely at that. What do you see? Why can I keep going, William? Is that a perfect square? Is that subtraction? Is that a perfect square? So can I go again? What about over here? Can I do anything here? Why not? Because it's not subtraction. Do I get to forget about this guy? No. So he is still there. I just can't do anything more with him. Can I do more here? What's the square root of x to the 8th? X to the 4th. Plus, what's the square root of 1? What's square root of 1? 1. Then I just do the same thing. X to the 4th minus 1. Can I go any further? Why can I go further? 4 and 1. Can I forget about these guys? Nope. x8 plus 1, x4 plus 1, x2 plus 1, x2 minus 1. Can I go any further? One more, can't I? X plus 1, x minus 1. Does everybody see? That's supposed to be x squared. Is everybody good? I put that one first because kids screw it up all the time. Where do you think most kids stop with number 1? At the very first one, because they are not learning what they're doing. They're learning steps. Square root the first one, square root the second one. Done. Why do you think I did all of this over here? Why did I make you think about x squared, x cubed, x4, x5, x6, x7? Why? There's a reason we teach you the why. Okay? Now, let's look at the second one, because the second one looks different. I just gave you a big, long lecture. Does looking different make any difference? No. If this wasn't here, could you do that? What would it be? X plus 15, x minus 15, right? Okay. If there was no x there, what would it be? Y plus 15, y minus 15. Yes? So now apply that knowledge to this. What's it going to be? xy plus 15, xy minus 15. And like all factoring, you can check it. Is x times x, x squared? Is y times y, y squared? Is 15 times 15, 225? Since these are the same with just the middle operation changed, doesn't that make the middle term drop out? Made it drop out here, made it drop out here. So there's no middle term here. Is everybody good? Do looks matter? No. So right here, you should write this. A squared minus b squared. Any perfect square minus any other perfect square always factors to this. The square root of a plus the square root of b, and then the same thing. Always. Is everybody okay with that? All right. Now let's prove it by doing something a little bit harder. You guys do 3. What's the first term? Z to the 4th. Plus, minus. What's the second term? 12. Am I done? I am done. Why? 12's not a perfect square, is it, William? So I'm done. Is everybody good? Everyone is good? Okay, now I'm going to make a small change. I don't want you to write this down. I want you to look. What if I made this 256. Then what goes here and here? Just look. Just think. What goes here and here instead of 12? 16, right? Now would I be done? Why? Because 16 is a perfect square, so I'd have to do just this guy again. Does everybody understand? Yes? 100%? All right. Look at the next one and see if you can figure it out. Does it work for our rules? Are they both squares? How do you know? What about this first term makes it a perfect square? You guys all told me that it would work here, so you must have a reason. Why does this work? 4 has a square root, which is what? 2. And x to the 6th has a square root that is what? X cubed. Because it's an even exponent, so it must have a square root. X cubed. Plus. Now, what's the square root over here? Square root of 25 is 5. What's the square root of y squared? Y. And then I just write it again. Minus 5y. And then I check. Are they the same binomials? Yep. So the middle term's going to drop out because it's plus and minus, so all I got to do is check the first two. 2 times 2 is 4. X3 times x3 is x6. 5 times 5 is 25. Y times y is y squared. Did I do it right? Yes. Now, I'm going to write, you guys hopefully have a tiny bit of room at the bottom of your page, unless you've been writing real big. I'm going to do 2 more to show you that the pattern always works, even when it's ugly. Okay? Is everybody ready? 32x squared minus 50y squared. Does that look like something that this will work for? What about that makes you suspicious that it might work? Squared and squared, right? But 32 and 50 don't work, do they? Do you have a mathematical tool that allows you to change those first two numbers? Hint, hint, you're about to be quizzed on it. Can I factor that? What can come out of there? 2, right? So 2 comes out here, and now I have 16x squared minus 25y squared. What does that look like? Now we're in business, aren't we? What do I get? What? 4x plus 5y and 4x minus 5y. Does everybody see that? So always remember, check. Because if it looks like you can go further, sometimes you can. You got to start recognizing when it looks like you can. Everybody cool? Now I'm going to do the hardest one I will ever give you on a test. I'll give you harder than this in practice, but on a test, I'm about to write the hardest one I would ever give you on a test. Everybody ready? X minus 3 squared minus 16. Look at it closely. Does it look familiar? What about this makes it look good, like it's a chance to do what we just did. That's a squared and that's a squared, isn't it? But this is really ugly, right? What did I give you away? How did I tell you to deal with that yesterday? What are you allowed to do with x minus 3? Can you make x minus 3 equal a? All right. So if x minus 3 equals a, how would you write this? A squared minus 16, yes? Everyone agree? How would you factor that? A plus 4 and a minus 4, correct? Well, what's a? X minus 3. So isn't this x minus 3 plus 4? And isn't this x minus 3 minus 4? So what is x minus 3 plus 4? What's negative 3 plus 4? X plus 1. And what's negative 3 minus 4? Really, El? X minus 7. Does everybody see? That is the hardest difference of squares question I would ever give you on a test. I will give you harder in practice because there's one way to make this harder, which is this. X minus 3 squared minus y plus 2 squared. Squared minus squared. Barf. But I'd only do that to you in practice. Is everybody cool? All right, now listen. I'm going to shut up until 2:30. That's 38 minutes from now. I'm going to give you a quiz. You work on it. If you finish your quiz, Sarah, don't put that away. I need it. Give me your book for a sec. If you finish your quiz, you go on to page 114 and 115 and 116. You got 4 days away from me. And 114, 15, and 16 is every kind of factoring you've already done. Okay? Everybody good? I'm going to bring the quiz around. Remember, the quiz is only multiplying and the first kind of factoring. Just GCF. All right? Everyone is good? I don't want to hear talking until everyone's done their quiz. Once everyone has done their quiz, then you are welcome to get together to work on page 114, 15, and 16. Okay? The quiz does not have trinomial. Well, no, you didn't study it for nothing, so you're going to get a second quiz on trinomials. And eventually you're going to have a test on all of it. Again, I remind you, when you learn how to make a left turn in a car, do you stop practicing left turns? No, you still need to know how to make a left. You're like a ninja, Sean.
You're so anxious to get
Pass those over around you. Make sure you put your name on it. It's only one side and it's only 12 questions. You have the rest of the period to do it. If you get it done, get your pink book out and get working. Okay? Okay. While I take attendance. I should just get a usual attendance thing where I can just click one button to eliminate all the people that never come to class.